right, so today we're going to learn about right triangle trigonometry. So we have one goal for today, and that is I can understand and apply trigonometric ratios. I would give yourself a 1 unless you took a geometry course at a former school. Okay, so here's our warm-up. Find the missing side and the missing angle. Go ahead and pause the video and try it yourself. Okay, so I need to find, I'll start with this angle right here. Okay, I already know this is 90, so I can do 90 plus 36.8. That's going to give me 126.8. And then I can do 180 minus 126.8. And that's going to give me 53.2 degrees. So I know this angle is 53.2 degrees. Now, I could have also said, well, this is 90, 180 minus 90 is 90, 90 minus 36.8. That will also give me the correct answer, which is faster. Okay, now I need the missing side. When you have a right triangle and you have one missing side, you can use Pythagorean Theorem to find it. So if I call this x, I can use Pythagorean Theorem where I do leg squared plus leg squared equals hypotenuse squared. X squared plus 4 squared equals 5 squared. Excuse me. X squared plus 16 equals 25. Subtract 16 from both sides. We have x squared is equal to 9. Square root plus or minus, square root plus or minus. I have x equals positive or negative 3. Now, can x be positive or negative 3? No. X can just be 3. So I'm going to put just 3 over here. It can't be a negative 3 for length. Okay? What if we asked you to find the missing angles and sides in this triangle? Well, I could say, same idea. I can do 90 plus 48, 180 minus that. Or I can do just 90 minus 48. That'll be even faster. That's 42 degrees. But now if you look, I have one side that I have, which is 7, but I have 2 missing sides. I cannot use the Pythagorean Theorem to find this. So could we find the angle? Yes. Could we find the sides? Not yet. Meaning in the future, we can very soon. What we're going to use to solve those sides is trigonometry. You may have heard of this math topic before, but not know what it's about. So what exactly is trigonometry? Trigonometry is a branch of mathematics concerned with angle relationships in triangles. The 3 most basic ideas in trigonometry involves 3 trigonometric ratios. So we're going to write down those 3 trigonometric ratios that we use in integrated. The first one is sine. Sine, how you spell it, is S-I-N-E, okay? The abbreviation is S-I-N. Now, because people see the abbreviation, they think it's pronounced sin. It's not. It's sine. Then there's cosine. That's how you spell it, co, and then same spelling as sine. The abbreviation is C-O-S. But once again, it's not you don't call it cos, it's cosine. That's how you say it. And the last one is tangent. Tangent's abbreviation is T-A-N. Okay, so first some basic terminology before we even get into trig. Consider the triangle below. I want to make sure you understand which side is opposite of angle A. So if you're not sure, what I'm going to do real quickly is I'm going to make a box. And I'm going to style. Can I fill it? Ooh, I can. What happened? Oh, it went away. Let me try that again. Let's make a box. I want a filled box. Yes, I could have just made a place where I scratched it out. And I'm going to because, there we go, style. Fill with anything. Okay, I just wanted a box that I can move around here. If you're not sure what's opposite of angle A, just, no way, cover up angle A. The side that's opposite is the only side that you can read right there, and that's side BC. okay? So that's just one way if you're having struggles with it. Now I look at it like this. It's opposite of it, so side BC is opposite of it. What is the hypotenuse? The hypotenuse is always opposite of the right angle. So here's your right angle. If you need to cover it up to see what I'm saying, the hypotenuse is AC because you don't use B, right? But you can just look at it as the longest side, AC. Last but not least, which side is adjacent to angle A? So here's angle A. Here's angle A. Well, it's labeled angle A there. Here's angle A actually right here, okay? The adjacent side is the side that touches that angle, but is not the hypotenuse. So if you look, it's not this. The adjacent side would be this side right here, AB. Now it changes depending on which angle you're looking at. So if I was looking at angle C, what's the adjacent side? The side that's not the hypotenuse that touches it, BC. Okay. So as we said earlier, the three main trigonometric ratios are sine, cosine, and tangent. So here's what they each are. Sine relates an angle to its opposite side and its hypotenuse. Cosine relates an angle to its adjacent side and the hypotenuse. And then tangent relates an angle to its opposite side and adjacent side. Now, if I told you right now, you need to know this, it's hard to remember when they're written like sentences like this. So we have a way of remembering it, and it's called Sohcahtoa. So first off, a trigonometric ratio is a ratio of two sides of a right triangle. So this does not work for triangles that are not right triangles. It has to be a right triangle. It has to have a right angle. So how do we remember these ratios? Okay, so it is looked at as three different things. So Sohcahtoa. Okay. What does the SO stand for? SO stands for that you are going to use the trig ratio of sine, and that is for the opposite, and the hypotenuse. So that's if you have the ratio of opposite over hypotenuse. Now, if you look right here, that's what it says right there, opposite side and the hypotenuse, right? So opposite side over hypotenuse. Ca stands for cosine. I'm just going to abbreviate cosine. And that is the adjacent side over the hypotenuse. I'm going to start abbreviating here because these words are long. Toa is tangent, is opposite over adjacent. Now, I don't write it like this, Sohcahtoa, because I think there's a more efficient, a better way of writing this. I write it like this. So, because it's opposite over hypotenuse. So, Ka, adjacent over hypotenuse. Toa, tangent is opposite over adjacent. That's how I write it. Now, it's smartest to write this down every single time that you use it. So when you're going to use it, write it down and then use it. Okay, so here's one way of using Sohcahtoa. It says, example 1, write the trigonometric ratio as a simplified fraction. So we want a ratio, right? So that means our answer is a fraction, and we want it simplified. Okay, so we'll do this together, and then I want you to try this on your own. All right, so we want the sine of angle A. So here is angle A. I'm just going to put a little red dot right in the corner. Actually, I'll do this right here. Here's angle A. No, I like doing the little red dot better. Little red dot right here. So I know what I'm talking about, that angle. All right, so I want the sine of angle A. That is the opposite side over the hypotenuse, right? Because it's so opposite over hypotenuse. So which side is opposite? 40. Over the hypotenuse, 41. That's it. All right, let's do cosine. Cosine, Ka, is adjacent over hypotenuse. I need the adjacent side, the side that touches A, that's not angle A, that's not the hypotenuse. That's the side right here, which is 9 over the hypotenuse, 41. And then tangent is the opposite. Tangent is Toa, opposite over adjacent. So I need the opposite side, 40, over the adjacent side, the side that touches it, that's not the hypotenuse, 9. Okay, so now what I want you to do is go ahead and try this for angle C. Now what you should be doing is putting some sort of marker here so you know you're talking about angle C. Go ahead and pause the video and try that on your own. All right, for sine, I need opposite over hypotenuse. So opposite's 9. There we go. Opposite's 9. Hypotenuse is 41. Cosine is adjacent over hypotenuse. The side that touches it, that's not the hypotenuse, is 40 over hypotenuse, 41, because that's adjacent over hypotenuse. Sohcahtoa, opposite over adjacent. The opposite side, which is 9, over the adjacent side, which is at 40. All right, so if you look, all this answer is the same as this answer, and these are reciprocals, but that's because you only have 3 things that you're working with, right? Okay, next it says, be sure your calculator is in degree mode, not radian mode. Let's check to make sure you're ready to go. Type in sine of 52 in your calculator. Do you get 0.79? If you don't, you're not in degree mode. So let's check my calculator. There we go. You can check yours too, and I'll show you how to fix it if it's not in the right mode. I'm going to hit clear. I'm going to hit sine. Sine is located towards the middle of my calculator. It says SIN. And then 52. Enter. And I did not get 0.79. If you did, you're ready to go. If you did not get 0.79, that means your calculator's in the wrong mode. So you're going to hit the mode button. The third option down is radian or degree. I'm in radian mode. I need to switch it to degree. And then I can hit quit, and I can try again. Sine of 52, hit enter, and now it's 0.789. It is in degree mode now. It will stay in degree mode until you take out your batteries or change. Change the batteries or take out the batteries or change it back to radian mode. Okay, so example 3 here says find the length of each segment round to the nearest hundredth. So our first segment is QR. I need to find the length of this segment right here, QR. Okay, so what I'm going to do is I'm going to call it X. It is my unknown. You can call it whatever you want. Okay. All right, so listen to the steps because they don't change much. So what you're going to do is I like to circle my angle. Here's my angle. It's 63 degrees, okay? I want to say how the two sides are related to it, the side that's X and the side that's 12.9. So we'll start with this side right here. Is this the opposite side, the adjacent side, or the hypotenuse? It is the hypotenuse, so I'm going to put an H there for hypotenuse. This side right here, is it the opposite side or the adjacent side? If you look, it doesn't touch angle P. It is opposite of it. So this is the opposite side. So I have opposite and hypotenuse. Which trig function uses O and H? If you forgot, write Sohcahtoa at the top. Sohcahtoa. O and H is used by sine. So I'm going to use sine. So I'm going to write down sine first. Okay? My angle, I always write down next. That's 63 degrees. Equals. And now you're going to have it equal to a fraction. It's the opposite side over the hypotenuse. O over H. So opposite is X. H is 12.9. All right, now I need to solve this equation. So this is because we're expanding off of this later. I'm asking you this question now. Am I solving for a side or an angle? You're solving for a side. Since you're solving for a side, you cross multiply. You're going to put this trig function over 1, and you're going to cross multiply. 1 times x is x equals, and then these two multiplied. Write the 12.9 first. If you don't, it's going to look like this. Sine 63, 12.9. that looks like 63. That looks like 6,312.9, right? So always write the other number first and then your trig function. All right, now I'm ready to put this in my calculator. Did it say where to round answers to? Round to the nearest hundredth. So I'm going to hit on first. There we go. 12.9 sine of 63. Close the parentheses. Hit enter. And I got 11.49 is the length of QR. So I called it X. So I'm going to finish up by saying I'm going to erase this X right here. I'm going to put QR is equal to 11.49. Oh, my fill's in, so I'm going to have to fix that later. Okay, next I have find BC. So same process, and I'm going to have you try. I'm going to do 2 more with you and then have you try 1 on your own, okay? All right, so first off, it says find BC, so label BCX. Here's my angle. Circle your angle. Say how your 2 sides are related. Are they opposite, adjacent, or hypotenuse? Let's start with this one right here. This side is opposite. It doesn't touch the angle at all. If it doesn't touch the angle at all, it has to be the opposite side. So I'm going to put an O there. This side right here touches the angle, so it's the adjacent side. It's not the hypotenuse because the hypotenuse is the long side. Okay, so I have O and I have A. Which trig function uses O and A? Tangent does. So I'm going to write down tangent. My angle comes next. 15 degrees equals. Then my fraction. Opposite over adjacent. 10.2 over X. Make sure you're doing O over A and not A over O. I'm solving for a missing side, so I'm going to cross multiply. I'm going to put tangent over 1. And now I'm going to cross multiply. I like to multiply whatever has X in it first. So I have X times tangent of 15 is equal to 1 times 10.2, which is 10.2. Now in the first one that we did, X was already solved for. This one, X is not solved for yet. You have to get X by itself. So how do I undo this multiplication? Division. So I'm going to divide both sides by tangent of 15. Divide by tangent of 15. Tangent of 15's cancel on this side. I have X equals. And now I'm going to type this in my calculator. 10.2 divided by tangent of 15, close the parentheses, hit enter. And I have 38.07. Once again, this was BC, not X, so I'm going to change it to BC equals. And I have BC is 38.07. Okay, let's try 1 more together, and then you can try 1 on your own and see how you did. This one says find FD, so I'm going to call FD X, and then I'm going to circle my angle. Okay, how are my 2 sides that are labeled related? Like, how are they related to? Are they opposite, adjacent, or hypotenuse? So I want to know what this side is, and I know what this side is. I do not care about this side. I don't use it. All right, so the side that's labeled X is my hypotenuse. This side right here touches the angle, so it's the adjacent side. So I have A and H. Which trig function uses A and H? Cosine. So I'm going to write down cosine. Cosine of, my angle always comes next, 39 degrees, equals my fraction. What am I doing? Adjacent over hypotenuse, not hypotenuse over adjacent. Adjacent is 20 over hypotenuse, which is X. Solving for a missing side, so I'm going to cross multiply. I'm going to put this over 1. I like to multiply whatever has X in it first. So I have X times cosine of 39 degrees is equal to 20. Divide by cosine of 39 degrees. Divide by cosine of 39 degrees. I have X equals, and I'm going to do 20 divided by cosine of 39, close the parentheses, hit enter, and I get 25 it went away. Oh man, 20 divided by cosine of 39, enter. And I got, oh, and my calculator reset, my mode did. See that? My calculator's finicky. Yours will never do that. All right, 25.74. Okay, why don't you pause the video and try finding IL on your own, and then come back and see how you did. If you got 4.54, you did it correctly. You can fast forward if you got it through that. If you didn't, then here's how you get it. You're looking for IL, we'll call it X. Here's my angle. I want to know how my two sides are related. This side doesn't touch my angle at all, therefore it's opposite. This side does, but it's not adjacent. That is the hypotenuse because it's across from the right angle. So this is my hypotenuse. So I have O and H. Which one uses O and H? Sine does. So I'm going to write down sine. My angle comes next, which is 27 degrees, equals O over H. Not H over O, O over H. X over 10. I need to solve this. It's a missing side, so I'm going to put this over 1 and cross multiply. 1 times x is x, and then I have 10 times the sine of 27. Put that in my calculator, 10 times the sine of 27. Hit enter, and I get IL is 4.54. And that's it. Okay, the last two are word problems, but they're going to end up looking like right triangles, and you're going to have one missing piece. Oh, also I want to point out, why can't I use Pythagorean Theorem on this? I can't because you don't have two sides. If you have two sides of a right triangle and you need the third side, you can use Pythagorean Theorem. But if we can't, that's when we use trig. Okay, here it says a ladder is leaning against a house. The angle between the ground and the ladder is 72 degrees. If the base of the ladder is 6 feet from the house, how long is the ladder? Okay, so let's draw what this looks like. Now, usually I just automatically draw a right triangle, like so. And it's filled, which is annoying, but I can fix it. I can do it right now instead of waiting until after my screencast is over because you guys don't mind, right? Or maybe I have to wait. I will wait. Okay, so here is my right angle. And you could have drawn it the other way. Like you could have drawn it this way if you wanted to. I just usually draw it the same way every single time. Okay, so we have a ladder leaning up against a house. So where's the ladder? I like to say this is A. Nope, I don't. I like to say this is A, this is B, and this is C. A is my altitude, right, the height. B is like the bottom, where the ground is. C is the hypotenuse. I also do E, F, and D, E, and F. We'll get to that a little later. Actually, let's do that right now. This angle we'll call up here, we'll call D. Then we'll call this one E, and this one F. Okay, so ladder leaning against the house. Which piece is the ladder leaning against the house? This piece is your ladder, right? That's your ladder. This is your house right here that's not exactly drawn in, right? So the ladder is the C right there. So I'll say the ladder leaning against the house is C, just so I know. The angle between the ground and the ladder. So here's the ladder, once again, C. The ground is B, so the angle in between is that angle E. So I'm going to erase that angle E right there. I need to get a different color other than red because you can't see it with all this pink. And I'm going to put this as 72 degrees, that angle. If the base of the ladder, so the bottom of the ladder is right there, is 6 feet from the house is right there. So they're saying if that is 6 feet, so I can erase this B and put a 6 there. Let's find how long the ladder is. So remember, this is the ladder right here, so that's going to be my X. Okay. So I can erase this A, F, D. I don't need it at all. Oh, my triangle I did need, though. So I need to solve for X. Okay, so I have to use Sohcahtoa because I only have one side. I don't have two. Here's my angle. How is this side related? It touches. It's adjacent. How is this side related? It touches too, but it's the hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine does. So I'm going to write cosine. My angle always comes next, which is 72, equals. And then adjacent over hypotenuse. Remember, it's Sohcahtoa. So I have adjacent and hypotenuse. That's why I'm using it. Make sure you're doing adjacent, which is 6, over hypotenuse, which is x. Solving for a missing side, so you're going to cross multiply. X times cosine of 72 is equal to 1 times 6, which is 6. To get x by itself, you have to divide by cosine of 72. So I'm going to have x equals, and now I'm going to type that. 6 divided by cosine of 72, close the parentheses, hit enter, and you have 19.42. These are word problems, so they have units on them. Feet. I knew that by looking here. Okay, very last one. A balloon is tied to the ground. The wind is blowing the balloon so that the angle between the string and the ground is 56 degrees. If the string is 8 feet long, how high off the ground is the balloon? Okay, so let's draw a triangle. I'm going to draw it the other way this time. Why not, right? Oh gosh, that is not pretty, and I don't want to fill it, so I'm just going to try again. Okay, that's good enough. Here is my right triangle. All right, so you have a balloon on a string, and it's tied to the ground, and the wind is blowing it. So people want to say like, oh, this is the balloon right here. The wind is blowing it, so it's on an angle, right? This is the string of the balloon. So there's your balloon tied to a string. The wind is blowing the balloon so that the angle between the string and the ground. So the string is that little squeaky line, and we know what the ground is. 56 degrees right here. If the string is 8 feet long, once again, this is your string. How high off the ground is the balloon? So I want to know how high off the ground is. That's x right there. All right, let's solve for x. Here's my angle. This is opposite because it doesn't touch the angle, and this is hypotenuse. O and H is used by sine. So I'm going to write down sine. My angle always comes next. 56 degrees equals opposite, which is x, over hypotenuse, which is 8. Put your trig function over 1 because you're solving for a side, and cross multiply. 1 times x is x equals 8 times the sine of 56. So notice x is already solved for. All I have to do is type this in my calculator. 8 times the sine of 56. And I get 6.63 units, feet off the ground. Oh, I did it again.